Welcome to Code Corner. This is a video series that we do at Mayfield Renewables where we talk about codes and standards as they relate to the solar and solar plus storage industries. Today, going to continue conversations on the International Fire Code, and specifically in this video talking about 2024 IFC and the large-scale fire test. So section to refer to is 1207.1.7. This gets referred to in multiple locations later on when you're reading through 1207. So taking a moment, looking at it, and kind of putting it to practice is an important thing. And one of the things I just want to put out there at the start of this video, so we're recording this April of 2025. This is actually quite a, I would say it's, always we're in improvement mode on this, and as an industry I should say. So we are seeing changes within UL 9540. We are seeing other standards coming to play, coming to the market to help really understand and put into practice what this large scale fire test is, what the industry is seeing, what AHJs are asking for. So I'm just gonna put that out there of what we have here is going to change. I know it is changing because there are, there's, as I record this, there's going to be a meeting happening within days of, large scale fire test protocols and things like that. So just know that you're needing to keep up on this, be looking for as current as information as possible to make sure that you have all the best information at hand when you're going through and evaluating this. So let's look at the language though, and we're looking at 2024 IFC language. And for those of you who maybe haven't seen a lot of our videos, when we put up code language like this, we highlight changes from previous code versions. So those highlights are not there to editorialize the code at all, but rather to point out this was a change from 2021 to 2024. And one of the big ones is right there. The first one is the numbering. So the numbering was different in 2021. And I'll just point out there are sections later on where they refer to large scale fire test, and they actually refer to the old numbering system. So if you get confused, if you're later on in code and it says, oh, refer back to this code section, you go back to that code section and it doesn't seem like it really applies. It's because there was just a minor typo in that. But 1207.1.7 is our large scale fire test, and I'm not going to read it for you word for word. It's a really good one though. I would encourage you to pause, read the language, and then being able to apply it might be a little bit easier after you digest it for a moment. But what I do want to do is I kind of want to pull out some key sections as we're talking about this. And so here we're just bolding some of the language that I want to draw your eyes to and I want to talk about. And so the first one is, in that first sentence, they talk about a large scale fire test in accordance with UL 9540A. So UL 9540A is as you can see there, we have kind of the copy or the front page there. It's a test method for evaluating thermal runaway fire propagation in energy storage systems. 9540A is for manufacturers coming to market with products now. This is a requirement to go through and get the 9540 listing. So any new products, actually any products that have been brought to market since the second edition of 9540, we've been utilizing 9540A to test those pieces, to test those systems and understand what happens in a thermal runaway event. We have just a lot of information. This has been a big topic for us, so I encourage you to take a look at our website. We have blogs, we have other videos on the topic itself if you want to immerse yourself more into the topic as a whole. But the test method is there to understand if we have cells within our battery systems that go into thermal runaway, what happens? What's released? What gases are released? Does that thermal runaway propagate to other cells, to other modules, to other units? And so it kind of grows and grows as the test goes along. But what I want to point out, and the reason why I highlight this here, is the 9540A is what is explicitly called out in IFC. And the other part, so that's part number one, 9540A being that test method that we're being called out. And then the other big one here is where the IFC language talks about showing that a fire involving one ESS will not propagate to an adjacent ESS. And this is where I would say that we run into a little bit of, I guess, trouble, it would be a way of saying it, in the sense that the 9540A test report, which is explicitly called out, if you go and look at that test report, that test method, there is, again, thermal runaway evaluation. The individual cells are driven into thermal runaway. There's a very prescribed method of what needs to happen at different testing levels, at different unit levels, at different for the ESS itself. What 9540A does not require is that the test, when the test is performed, that any of the gases are ignited and a fire, a flaming fire, is purposely started. So there's language in 9540A that talks about no visible flame outside of the unit and things like that. But one of the things that we're seeing is AHJs are reading this, and they read fire code, and they look at the 9540A test report, and they see a discrepancy because that the 9540A test report doesn't show a fire. And so in their minds, a fire being flames, the thing actually lit on fire and we actively burning, in order to show that the fire won't propagate from one ESS to an adjacent one. So we have seen jurisdictions take that approach. Now we're in this spot here where 9540A is the only thing that's being referenced. 9540A doesn't require that. So this is potentially a conversation that you need to have with your AHJ, if that is their stance that they're taking, and this is something that's known in the industry. So there's a couple things that we're seeing. As I mentioned, in the very beginning, there's movement being made on these standards, and one of the things that's being addressed here is UL itself has task groups that are being put together to address this large-scale fire test, to address actually starting igniting the gases in order to see what happens when those fires happen. So there is movement within 9540 itself in order to address this. And there are other standards. I'm going to show you one here in a minute. There are other standards that have been released already that address this as well. So before I get into that though, real quick, the language here is what the intention is for the energy storage systems. We've talked about this in other videos as well for IFC specifically, but we have size and separation requirements. We have to have we can't exceed a certain size of kilowatt hours, or we have to maintain a certain separation between units in order to meet fire code. And the exception always points back to this, saying, unless there's a large-scale fire test that shows that it's safe to put those units close together, or it's safe to have more than a certain amount of kilowatt hours inside the unit. So that's what the intention of this standard is, this test method is, and it's, for the most part, it's very effective. And if you go and you read the test reports, you will see what the requirements are, or I should say not the requirements, but what the testing shows when the manufacturers go through this test. So highly encourage you to go look at those reports. They're pretty enlightening when you look at them. There's very often pictures showing what happened when they did the different levels of tests, and kind of how the modules reacted, or what the end result was and things like that. So this is the information that you would need to provide to the AHJ in order to meet those exceptions for the size and separation of ESS units. So as I mentioned, there are other standards that are being worked on, and in this case we're looking at the CSA ANSI C800 standard. And so CSA is a nationally recognized testing lab. They are a lab that can go through and do tests to UL standards, and then as you see here, they actually have the ability to write their own standards. And so they've gone through the ANSI process, and they have this this C800 that you can see here. It's first released back in 2024, and now in spring of 25, they've actually gotten it through the ANSI process. Now, the interesting thing here is, if you're interested, you can go find, there's some videos out there that show kind of manufacturers going through this process, and I'll give you a little bit of a reference here in the next slide. But the interesting thing here is we have a standard, a repeatable test that can be done by other nationally recognized testing labs. That one of the big things here is part of this C800 is intentional ignition of flammable gases. So they went that step preemptively. They took that step of, hey, we know these gases that are being released are flammable, and we know that 9540A doesn't require that, so we are going to have a standard that does. And we light those gases on fire, and we see what happens to the unit, and that will give us, inform us on give us more information on what happens in a really bad fire event. And so we do have this intentional ignition, and what they're ultimately looking to see is how does that affect other ESS units that are installed, adjacent to it. But the trick here is, I've had this question asked, well, now that we have that this test standard, will this suffice to the AHJ when being asked for that large scale fire test? And where we're up there is, or what we're up against there is, in International Fire Code, the 9540A is referenced, but not this standard. So yes, it's a good standard. Yes, it gives us great information, but it's not part of the code language. And so this might be, again, another discussion to have with your AHJ, making sure the fire code official understands what this test standard is, that it's not just some fly-by-night act. It's an ANSI standard. It's very rigorous. It's gone through a lot of reviews and stuff like that in order to provide really good data for the fire code officials. And then, as I mentioned, 9540 is going through, and they're going through their own test standard process of doing something very similar. So the industry and the NERDLs are looking at this, and they are understanding, hey, there's a gap here, and they're doing their best to fill it. Real quick, BYD is a manufacturer of energy storage units, and they've actually gone through that CS800 testing. They actually did it before late 2024, so they kind of were on the front edge of all of that. And really, you can go find, they have a video on their site, and you can see what happens when they intentionally ignites one of their units on fire. And basically, they're showing it doesn't propagate, it doesn't spread out to these other units. And so part of that testing for the C800 is we have multiple fully populated units. We want to see what happens in kind of a real world environment. So I encourage you to go take a look at that if you'd like, in order to see what that test is doing and how it's being approached. All right, so that's large scale fire test. I know it's not all the answers. I know that it's a work in progress, so I highly encourage you to stay on top of it. Here at Mayfield, that's one of the big things that we're doing, is we're really paying attention to that and how it's moving through the industry. So we're constantly releasing information as well as new stuff is announced and as new information is out there for us. I would encourage you to take a look at our courses that we have on our website. If there are other topics, fire code related, National Electrical Code related, or other standards or topics within the industry, we have a number of courses on our website. We'd be happy to have you take a look at those and see if we could help you out on your education within the industry. And then finally, questions or comments are always welcome. Love to hear from you. So if this or other videos, you have any sort of questions, here's our contact info. Feel free to reach out to us. Also, if there's a topic that you want to hear us talk about in the future, let us know. It's helpful for us to hear what the industry's wanting to hear about, needing to hear about. So thanks for your time. I appreciate it, and I look forward to seeing you on a future Code Corner.